It doesn't give me much inclination. I can't really see where it says we are now recording. I see some dots down there. Maybe that's what that is. Don't know. Oh, here we are. A question on the general social survey was, how many family members do you know that are in prison? The results of 499 respondents indicate that the mean number of family members in jail is 1.22 and the standard deviation is 0.059. This would definitely be a survey we could not carry out in this class because that's certainly privileged information. Let me think. Do I have any family members in prison? I think I'm okay. I think I'm at a 0. It says here, what shape would you expect the distribution of this variable to have? So that sort of corresponds to if I was going to make a bar graph of this thing. Of the number of family members in jail, you'd have to make a guess for what it looks like. And you would guess, I suppose, the majority of folks would say none. That'd be my guess. But then there might be a good chunk of people that have 1 or 2. Maybe it's both your brothers end up in jail. Don't ask me. And then past there, I would think it'd be pretty small. So if that would be your guess, and that would mean, so it'd be skewed, as they say, skewed right, in the direction of the long tail, like that. And if you had to put reasoning, would be most, we'll say 1 or 2. A few, we'll say more. And so that makes the histogram look like that. That'd be skewed to the right. So we're good there. It says B, that's for A. Yeah, for B it says, construct and interpret a 99% confidence interval for the mean number of family members in jail. Here we go, wait a second. Notice the distribution is not normal. But the sample size is 499. So we can proceed. The confidence interval formula looks like x bar plus or minus t alpha over 2 s over root n. And we need to know, it doesn't say what kind. Oh, it's 99%. Okay. 99% confidence. I'm looking for my t-table. It's here somewhere. Here we go. So we have a couple of challenges. First of all, what row of the table do you think you're going to use? The degrees of freedom is 1 less than the sample size. It's going to be 498. But the table doesn't have 498. So what do I use? I'm needing help.
You would use 100.
Use the next lower size. So we're going to use 100. And then we want a 99% confidence. So alpha over 2 is 0.01 over 2. That's 0.005. So I'm down here at 100. And I'm up here at 0.005. Where is it? Are we over here? Really? 99, yeah, 0.005. Here we go. So that's a pretty high level of confidence, 99%. Really? I have to keep checking. It says 99. It does. Okay. So ordinarily, if that was Z, I'd use 2.576, this big number. For t, I end up using something a little bit bigger than that, even 2.626, using 100. And really, these values are pretty close together anyway, so even if you messed up, you'd still get pretty close to the same interval. So we use 2.626. T equals 2.626. And then we go x bar was 1.22 plus or minus 2.626. S was 0.59 over square root of 499. Imagine this is going to be pretty narrow because that 499 is so big that this will be a small fraction times 2 plus or minus 1.22. Let's see what it looks like. 1.22 plus 2.626 times 0.59 divided by the square root 499. Okay, there it is. Double check it. I'm happy, okay. 1.289. And I'll do the minus side of this interval. Here we go. Second, enter, go back here. Make it negative, go. 1.151, I guess. 1.151, like that. So pretty close to 1.2, not the margin of error is not very big. And we'll see how the calculator handles this too. So I'll go to stat tests. I'm looking for a confidence interval, a t interval. That's what we have. And then we have stats, okay. X bar is 1.22. S is 0.59. And N is 499. Confidence level, a point, oops, clear that, 0.99. And off we go. Hope to be vindicated. Don't have much confidence right now, but we'll just do it anyway. So 1.1517 to 1.2883. There we go. It uses more significant figures than we used here. And the t in the calculator is more accurate than the t here, so we won't get exactly the same answer. Okay. Got that done, okay. Questions on that? Okay. Keep moving along. I'm going to zoom here. According to the National Center for Health Statistics, 22.4% of adults are smokers. A random sample of 300 adults is obtained. Part A says, describe the sampling distribution of p hat. I'm looking for help. I'm starting, oh, I messed up here. I'm going to clear this. So that's asking you what kind of distribution p hat has, and then what characteristics might it have, mean and standard deviation, stuff like that. I'm asking Kat, can you help me?
Would it be normal?
P hat is normal, can be considered normal. There's some stuff we have to check. Does Dylan happen to know what we have to check to make that happen? If something, something, something. What's the stuff we have to check?
Isn't it if h of O is equal to 0, and if h of
Those are nice words, but they're not the right words for this one. How about Michaela? Do you know what we have to do here? Uh-oh.
I don't.
It starts like this. N, P. Any ideas? I'm going over to Olivia. Someone's going to help me. It's like playing hangman. I'll put more stuff here.
Just play hangman. Okay.
Yeah. Any idea what goes in those parentheses?
Um,
Well, either you know or you don't. So okay, that's okay.
I don't think I do.
Okay, how about Crystal? Do you know? I'll give you more help.
Professor, I know now.
That's not fair. I gave you a bunch of hints. I'm at Crystal. Do you know Crystal?
I know that it has to be 10 at the
Okay,
end.
10 goes over here. We're making progress. Hangman, you wouldn't have been hung. How about Alyssa? Can you finish this off?
I could try. Is it the P minus N?
No, it isn't. I'm at Thorin now. How about Thorin? What goes in here?
Is it 1 minus P?
It is. So luckily, because I was asking you to do this cold, we can look in here, and somewhere here it says we're allowed to use Z here if NP and 1 minus P is at least 10. If you don't know what P is, you can use P hat there. Here they're telling us what P is. So we've got everything we might need. So we'll check that. N is 300. The P is 0.224. And the 1 minus P be 0.776, I suppose. Like that. And we compute that 300 times 0.224 times 0.776, like that. Oh, that'd be nice if I could see it. Okay. There it is. 300 times 0.224 times 0.776. 52. So yes, it's big. And not only that, P hat has mean, let's see what it says. Let's say up here something about P hat. Here's P hat right here. The mean of P hat is P. At sigma P hat looks like this. Okay. So that means the mean will be 0.224. And the standard deviation is the square root of P 1 minus P over N. So let's do that. So we get a square root there. We got 0.224 times 0.776 divided by 300. Well, that's NP 1 minus P over N square rooted. Okay. And that's 0.0241 maybe. 0.0241. You expect it to be a small number because these are percentages. Yeah, it's like 22%. So that'd be 0.224. So this is going to be point something something anyway, probably. So don't get scared by that. And so we've got a mean and standard deviation. We know that it's normal, which means we can compute Z. So for B, at least 50 is P hat at least how big? And I'm at, I think I'm at Tatiana. Can you help me with that? Because they tell you the number of smokers has to be at least 50. What does that make P hat to be at least how big?
I'm not sure.
Well, how would you convert 50 into a percentage? What do you have to divide by?
100.
Wait a minute. How big's the sample?
300.
300. So 50 out of 300 is what fraction? We go 50 divided by 300 like that. So 0.167 maybe, something like that, 0.167 like that. Okay. So we're going to compute Z. Now compute Z. I'm in trouble now. Oh my phone. It's not supposed to be ringing. What do you think it is? Hello? It's nothing. Okay. I wasn't speaking Spanish, so they didn't talk to me. I think that's what it was. Donnie, I need to compute Z. Can you help me? I got pieces here. Here's the mean. Here's the standard deviation. Here's the value. I need a Z. Are you there even? Donnie? There you
Yeah,
are.
I'm here.
So you need value minus mean over standard deviation. Could you help me put them in here? What goes in front here?
It's the point.
They're all point things. Yeah.
Yeah. It's 167.
Okay. And then minus the mean, which that's a 224.
0.224.
And then downstairs, here's the standard deviation, 0.241, like that.
Yeah.
So what that is this guy right here. P hat minus P over the square root of P1 minus P over N. We're trying to compute a probability for P hat. So you compute Z this way, and then you can look it up. We're worried about at least 50. So we need the probability of, it's at least, being at least this big. And so we're going to go to the tables and have to worry about looking at the wrong side. Here we go. So parentheses, 0.167 minus 0.224, close it up, divided by 0.0241. Keep checking on that. Looks all right. Minus 2.3. So 50 out of 300 is not very many. 22% would have been 66. So at least 50 should be quite likely. We have minus 2.365. And that's Z. So minus 2.34. Minus 2.34 sits here. So we get 0.0096, but we have to go on the other side. So 1 minus 0.009, double check that. 234, sorry, 237. Oh, that's no good. Okay. 237. It's over here. 0.0089. So 1 minus 0.0089. That's 0.9911, like that. So what is it, probably at least 50? It would be the answer. Probability of at least 50 out of 300 if the actual mean is 22.4%. This is taking longer than I thought. It says here, would it be unusual if a random sample of 300 results in 18% or less? We'd have to then compute Z for 18%. See how that stacks up. Z is 0.18 minus 224, or 0.241. Let's see what that does. This is for C. Parentheses, 0.18 minus 0.224 divided by 0.241 minus 1.82 57, whatever. So I would say that's close to 2. So a little unusual. But not very unusual. Pretty much has to be past 2 to be considered very unusual. So slightly unusual. I wonder what the book says for that, since it's so close to the edge. My book is gone. That's funny. It's a book problem. I was going to look it up, but you know what? I don't know where my book is, so it's going to make it hard to do. Where I went. Oh, that's slightly annoying. There it is. See if I can find it. It's a proportion section. I'm in here. That's in chapter estimating proportion or testing proportions. I think it's 436. Sounds like 436 might work. Yeah, so I think it's in the chapter test. That came out of the chapter test. I can't find it. I'm looking hard. Maybe it's at the end of chapter 9. Since it's not really hypothesis testing, it's fake hypothesis testing. I give up. It's in the book someplace. We don't have time to go hunting for it. Let's just finish this off. I'm going to stop recording for a minute.